Well, welcome to lesson number 11, Learn C Programming on the Raspberry Pi. Well, last day we were doing our first program concerning how to work with devices on the Raspberry Pi. We used a single LED to turn it on and turn it off. And we'll be doing something similar today. So let's get started. First we'll SSH over to our Pi. And here we are. And we'll start our editor. Okay, so you can see where we left off on lesson number 10. Just to go over it once more, you notice that because we're using the Wiring Pi library, we had to include the Wiring Pi header file. We also set up a define here to define our LED on GPIO pin 25, and now we're using Wiring Pi functions. The first one is Wiring Pi setup GPIO, initializes the library for us. The next function we used is pin mode, to say that pin 25 is set for output, and the next function we used was digital write. So we set the pin 25 or GPIO 25 to a high. Then the next function was delay for 1 second. And then we set the GPIO 25 to a low. And then again delay for 1 second. So I put over here in this list here of functions that we've used so far in our course. We started off by just using, in the early days, we used printf and scanf. And remember that we had to, on the command line, we had to include the C library. Well, we didn't have to include it because it's included by default, but if you wanted to, you could actually put this on the command line. We also used a couple of functions from the math library, the power function and the square root function. In that case, it was mandatory to include the math library. Well, last day we started using the Wiring Pi library, and we learned 4 functions from the Wiring Pi library: the Wiring Pi setup GPIO function, the pin mode function, the digital write function, and the delay function, and they are all given to us by the Wiring Pi library. Okay, so let's try running this thing again just to see how it works. You'll notice before I do that though is that last day I had 1 LED and today I have 3 LEDs. I have a red one, a green one, and a blue one. So I'm using 3 different GPIO pins. In other words, I'm using GPIO 25, I'm using GPIO 24, and I'm using GPIO 23. Okay, I think we can probably look that up just to get a better look at it. I think it was, no, not this one. This one here. So let's have a look. So we were using GPIO 25. You can see it right here. But today, because I have 3 LEDs and 3 resistors, I'm using 25. I'm also using 24, and I'm using 23. So I'm using this pin here, this pin right here, and also the pin beside it. I don't know if you can see it that well on the on the image here, but anyway. So we'll be using 3 GPIOs. Of course, our program here will still work even though we're only using one of them. So we can try it. So let's try to build it first of all and see what happens. And you'll notice that the compilation failed because we don't have access to these functions. In other words, we did not include the wiring pi library. If I was to do this on the command line, I believe it was lesson 10. I would say something like this. I would include the wiring pi library on the command line. Well, by default, in the editor Genie, the wiring pi library is not included on the compilation. So what I'll do is I'll add it in. I'll go to set build commands and I'll add that wiring pi library onto our compile command. So see where the build is here. I will just add it right after that, -L wiring pi. And remember, the P is uppercase. Okay, so I add that in on my build command and I save it. Now if I go and build it, it should work, and it says compilation finished successfully, so I got a good build. And now what I can do is I can just run it. I can execute the program here, execute, and you can see the red LED is going on and off, I believe 10 times right here. And you notice it's not very bright today because what I did was, instead of using 100 ohm resistors, I changed them to 4.7k ohm, so 4,700 ohms instead of 100, and that really limits the current a lot, and it makes the LEDs a lot less bright. Okay, so just to verify that we did get our last day's program going, and let's now write a new one. So in today's lesson, we're going to use 3 LEDs. So let's put in 3 defines. So the first one is going to be a red LED, and then green, and that was number 24 using GPIO 24, and the third one blue was using GPIO 23. Well, what we did here was we set the GPIO to be output. Well, we have to set all 3 of them now to be output. So what I'll do is just let me take this out here, output, and I want to add in the green and the blue ones, the green and the blue. So this one will be green, and then we have to do the blue. Okay, so Let me eliminate some of these comments here to make it a little bit easier to code. Okay, so what we want to do here is we want to turn the red one on, and then we'll wait for 1 second. Then we'll turn the green one on. So we'll change that to a high. And after we turn the green one on, then I would like to turn the blue one on here. So we went and turned the red one on, we wait for 1 second, we turn the green one on, we wait for 1 second, we turn the blue one on, we wait for 1 second, and then what I want to do is I want to turn them all off. So let me just take this code here, I'll just copy it here, and this time I'll turn the red one off, I'll turn the green one off, and I'll turn the blue one off. And we're going to do this 10 times. Well, maybe 10 times might be a little bit too many times, so let me change that to a 5. Okay, so now let's save this guy as a new file. I'll save it as, instead of lesson 10, I'll put it into lesson 11, and I'll call it LEDs, because it's more than one LED, and I'll save that guy. And what I can do now is I can build it, and we'll see if it actually compiles. Oops. Oh, shouldn't be off. Sorry. Should be low. I guess I could have defined off as a 0, and that would have worked if I would have done that. Okay. So let's save this guy, try to build it again, see what we get. Okay, it seems to have worked. So let's try running it and see what happens. Execute. There we go. So the red comes on, the green comes on, the blue comes on, red goes off, green goes off, blue goes off. And it just repeats that same kind of sequence 5 times. 5 times on, 5 times off. Well, it looks pretty good. And we're done. Okay, so there's our first program for lesson 11 using 3 LEDs. And again, we're using the same functions we used as we used in lesson 10. Remember, you always have to initialize the GPIO library or the wiring pi library. Then we have to, all the pins we're using, we have to set them either as input pins or output pins. Output pins means we're going to set voltages on them. Input pins means we're going to read what the voltages are. Okay. And then we have a for loop here where we go through, basically turn the red on, wait for 1 second, turn the green on, wait for 1 second, and so on. Then we go and turn them off again. Okay, looks good. Let's try another example now. Let's see, what could we do? Well, maybe we could do a counter to count binary. Now, I guess most of you probably are unaware of what binary is, so let me make a new document here, and to show you how to count in binary, it's quite simple. Binary just has a 0 and 1, so we don't have any other digits to deal with. In base 10, we deal with digits 0 through 9. So in binary, where we count, we start with a 0. Actually, you know what? Let me put, can I put line numbers here? Let's see, preferences, display line numbers. Okay, so a number 1 is a 1 in binary. 1 is a 1, but a 2 is a 1 0, and a 3 is 1 1, and a 4 is 1 0 0, and a 5 is 1 0 1, and a 6 is 1 1 0, and a 7 is 1, and an 8 is 0, and a 9 is 1 0 0 1, and a 10 in binary, a 10 in binary is 1 0 1 0, 11 is 1 0 1 1, 12 is 1 1 0 0, 13 is 1 1 0 1, 14 is 1 1 1 0, and 15 is 1 1 1 1 1 1, and 16 is 1 1 2 3 4 0. So if you look at the pattern, you can see about when you want to count in binary. Well, I don't have a 0 here. A 0 is a 0, of course, but in binary we only have 1s and 0s. So a 1 is a 1, a 2 is a 1 0, a 3 is 1 1. So we just keep filling up those zeros. Once we get to a 4, we have 1 0 0, then we have 1 0 1, 1 1 0, 1 1 1, and then we add another 0 on. So whenever we fill it up with 1s, the next one is we just add another 0 on. So we fill up with 1s here, we add another 0 on. We fill up with 1s down here, and then we just add another 0 on. So you can see what the pattern is. Well, we have 3 lights. Well, with 3 lights, we should be able to have a counter that counts up to 1 1 1, which is a 7. Okay, so let's see if we can make these lights count for us somehow. So the first thing we're going to do is we're going to count from 0, we're going to count to less than 8. So we're going to count 0, 1, 2, 3, 4, 5, 6, 7. So we're actually counting 8, but that's because we include a 0. Okay. Well, now what I'm going to do is I'm going to introduce you to a new statement in the C language, something you haven't seen yet, which is, we call it the case statement, but it's actually, we actually use the keyword switch and case. So let me code it in first a bit for you so that you can just get to see what it looks like. SWITCH, switch on I. And what I'm going to do then is case 0. So if I is 0, what do I want to do? Well, if I is 0, I want to turn all 3 lights off. I want to turn all 3 lights off. So let me get rid of these delays in here. And since we want all 3 lights off, what I'm going to do is just do this, and let me just straighten it out here a bit so it looks a little bit better. So if I is 0, we turn all 3 lights off. But what happens if I is 1? Well, that's a different case. Case 1. So what do we do if I is 1? Well, let's just copy this in here. It's going to be a long program, but it should be fairly easy. So what we want to do now is the red, green, blue. So if we're going to look at the counter, this is red, this is green and blue. We want to turn the blue one on to signify 1. So I'll just take the blue one here and I'll just put it high. So that takes care of 0 and 1. Well, what do we do if we have case 2? Well, let's just copy this again. So with the 2, we want to have the green light on and the other 2 off. So we'll put the green light will be on, which will be high, and the other 2, the red and the blue, will be low. And then we go to case 3. Well, with 3, just copy this again. With 3, we want to have the green and the blue on, and the red should be off. So the green and the blue are on. Let me turn the blue on here. Okay. So we've got, oops, hang on a second here. We've got, out of the 8 cases, we've got 4 of them coded. We still need to code 4, 5, 6, and 7, so we need 4 more cases. So just to make it easy, I'm just going to copy all of these 4 cases. I'll just copy them down here. So make this a little bit bigger so you can see what I did. So I had case 0, 1, 2, and 3. Now I want case 4, 5, 6, and 7. So with the 4, we want to have the red on down here, and the green and the blue are off. So this one should be high. So the red is on, and the green and the blue are off. Now with 5, case 5, we would like to have the red and the blue on, but not the green. So with 5, we want the red and the blue on. So the red is on, the blue is on, but the green is off. Case 6, we want to have the red and the green on, but the blue off. Red and the green on, and the blue is off. And then the last case, we want to have them all on, because with a 7, you see all the lights are on with a 7. Okay, so we are going through this switch statement. Let's put an ending brace here, and I'm also going to put in a delay of, well, let's put a delay of 2 seconds in our counter. Can I make this guy a little bit bigger so you can see the whole program? Might just fit. Let's try it. There we go. So we're doing a for loop here, which goes from this brace all the way down to this brace here. And inside the for loop we have a switch statement that is going to select one of these cases. We have 8 cases, case 0 to case 7, because I is going from 0 to less than 8. Well, less than 8 is 7. So the first time I is going to be 0, which means this case is going to be in effect, which all the lights are going to be turned off. Break means that it goes to the bottom of the case statement and then it comes back up to the for loop. So basically exits the case statement. Okay, so let's save this guy. Let's see, File, Save As, and we'll save him as binary. Let's see, we'll call it binary in Lesson 11. And let's see if we can compile it. Build. And it did compile successfully. And let me save this document here. I'll save it as, I'll just call it binary.txt. So that'll save this for me. Okay. So it compiled successfully. Let's run it. So you can see it compiled successfully because I have the object code here. But the executable is binary. So I can run it now. We can see if our counter works. So 1, 2, 3, 4, 5, 6, 7. Oh, program finishes and all of our lights stay on. I guess it would have been nice to actually turn all the lights off at the end of our program. So let's add in, after the for loop is over, let's just turn all of our lights off. So I'll just take that and I'll copy it down here. Okay, so when the program, when the for loop is over, our counting is finished, we'll turn all of our lights off. So let's save this guy. I'll build it again. And I will run it again. And hopefully this time they'll all turn off. 2, 3, 4, 5, 6, and 7. Very good. They all turned off. Okay, so there you have it. 2 more little programs. Binary.c and LEDs.c for today's lesson. And the functions we used are all the same. We haven't used anything new, haven't used anything different. We're still using just these 4 functions from the Wiring Pi library. We're not using anything from the C library. We're not using anything from the math library. And that seems to be enough. Okay, I think we're done for today. Well, we're done for this lesson. So this is the end of lesson 11. Please continue programming. Try experimenting with different LEDs. Change the code, modify the code, hack the code. Try different things and keep learning. And we'll see you later for lesson number 12.